Hey everyone, welcome back to the channel where we unravel the weird and wonderful mysteries of science. Today we re-tackling a question that sounds like a riddle. Why does hot water sometimes freeze faster than cold water? I know, it sounds completely backward, right? You'd think the colder water has a head start, so it should win the race to become ice every single time. But science is full of surprises, and this is one of the coolest, or should I say, coldest. Stick around because we're about to dive deep into this frosty paradox. Have you ever heard of the Mpemba effect? It's the official name for this bizarre phenomenon. This was named after a Tanzanian student, Mpemba, who noticed in his cooking class that hot ice cream mix froze faster than the cold mix. He asked his teacher why, and nobody had a good answer. So, he and a physicist teamed up to investigate, and they confirmed it. Under certain conditions, warmer water can indeed freeze before cooler water. But how on earth is that possible? Well, scientists have a few leading theories, and it's likely a combination of factors working together. First, let's talk about evaporation. When you heat water, it evaporates more quickly. As the water turns into vapor and escapes, the total amount of water left in the container decreases. Less water means less mass to freeze, so naturally it can reach freezing point faster. Think of it like this. If you have to freeze a small puddle versus a big one, the small one will obviously freeze first. Hot water essentially gives itself a head start by reducing its own volume. Another key factor is convection. In warm water, you have these things called convection currents. As the hotter, less dense water at the bottom rises, while the cooler, denser water at the surface sinks. This constant circulation helps the water lose heat much more efficiently and evenly, kind of like a self-stirring pot. In cold water, this process is much slower. The coolest water just sits at the top, acting like an insulating layer and slowing down the heat loss for the water below it. So, the hot water is just better at getting rid of its heat. And there's more. Dissolved gases also play a role. Cold water can hold more dissolved gases like oxygen and carbon dioxide than hot water. When you heat water, these gases are forced out. It turns out that these dissolved gases can slightly lower the freezing point of water. So, by getting rid of them, hot water has a slightly higher freezing point, giving it another small advantage in the race to become ice. It's a combination of all these little things, evaporation, convection, and dissolved gases that come together to create the Mpemba effect. So, the next time you're in a hurry to make ice cubes, you might actually want to start with warm water. It's a fantastic reminder that even something as simple as a block of ice has its own fascinating mysteries. Science is constantly surprising us, showing us that our everyday intuition isn't always right. What seems like a simple rule can have complex and mind-bending exceptions. If you enjoyed having your brain twisted by this cool science fact, make sure to hit that like button. And don't forget to subscribe and turn on notifications so you won't miss our next dive into the amazing world of science. Thanks for watching, and I'll see you in the next video.